All right, perfect. Now in this lesson, we're going to be adding the game manager. So this will help us coordinate all the actions between all the elements of our game. So let's create it. All right, so to do so, let's create maybe a new game object to organize our elements. So let's call it managers. Managers, all right. And under it, let's create a new empty game object and call it game manager. Perfect. Now let's open the scripts folder because we are going to create its script right away. So let's create a new script and call it game manager. All right, perfect. Now let's grab it and drop it onto our game manager game object. Oh, it's compiling, sorry. I think it should. All right, it's all good now. Let's open it. Perfect. And before everything, let me explain you something. So this game manager will be unique in our game. So we will turn it into a singleton to be able to use it to coordinate many actions in our game. Okay, perfect. To do so, let's create a new public static instance of our game manager. Okay. Then in the awake method, so the awake method is a method called even before the start method, we can say if this instance is different than null, then we want to destroy this game object because it means that we already have an instance of a game manager somewhere else. We don't want to get two instances of the game manager, we only need one. Else instance equals this. Perfect. That's that simple. Okay, so now we make sure that we have only one instance of the game manager. Perfect. Now what do we want to do? Let's create a new enum. Okay, let's make it public and let's call it enum game state. Okay, so we're going to add some values inside of this. So we can say if we are in the menu state, so menu, so we're not playing. If we are in the game state, we can also have the level complete state or the game over state, because we will have a game over when we don't have enough runners to run, when we reach 0 runners. Okay, cool. Now let's create a new method, a new public one called set game state. All right. And this will take a game state as an argument and it's going to be game state. Okay, perfect. But before this, let's create a new private variable that's going to be of type game state and let's call it game state, like so. Okay, perfect. Here, when setting the game state, we can say this.gameState equals game state, because we will be able to call this method from anywhere in our game. Okay, for instance, just to give you a quick example, when we are going to press the play button, it's going to call this set game state to set the game state. Thus, all of the other components of our game will know that we've just started the game state. But now, even if we call it, nobody knows what we've done. So for that, we are going to create an event or an action here. So let's use the system library. Okay, let's create an action. So let's make it public, static, and action that will take a game state as argument. Okay, cool. And let's call it on game state changed. So basically an action or an event is a message the game manager will send, and whoever wants to hear it will hear it and apply some logic after that. Okay? So now when setting the game state, we can call on game state changed dot invoke game state. I'm writing it this way because if we don't have any subscriber to this event, we won't have an error, because if we just call it like so, we might have an error if nobody subscribed to the event. So that's why I'm using this syntax. And for now, we're pretty much done for the game manager. So let's add some UI. All right, perfect. Let's drag our water and drop it into the gameplay just to better organize our project. And let's create a new game object and call it UI, like so. Now we are going to create a new canvas. So a canvas is just a game object that holds all our UI pieces. Okay, perfect. Let's call it canvas. Then in the canvas scaler mode, you want to select scale with screen size because it will simplify the scaling between all the different resolutions of the end devices. So let's say we are going to use a 180p resolution, and let's match the height of the end device because we are making the game in portrait mode. If you were to make the game in landscape mode, you would select the width. Okay, cool. So right here, now that we have our canvas, let's create a new panel that will hold all of our menu elements. So let's call it menu. Okay, perfect. So now you can see that it has created an image that is stretched to fit the screen. So I can just remove it and set the alpha to 0 because I won't use it for now. All right. So for now, our menu will only hold a new UI element, which is going to be a button. And now you can see that the button has been created. So to have a better view of our UI, you can select canvas and press F in the scene view. Then you can click on this cone here to have a front view of the canvas. All right, perfect. So let's rename our button because it's going to be our play button. Okay, cool. Let's press T to get the rect transform tool. Okay, rect tool. Let's make it a bit bigger, drag it down, and let's anchor this button to the bottom of the screen. This way, Unity will try and keep these proportions on any end device. Okay, cool. So let's maybe change the text right here, make it best fit to best fit the width of or the size of our button, and let's write play. We can also change the font to use the Milky Coffee font we've imported before. Okay, perfect. So next, we are going to add some logic to be able to move the player whenever we press the play button, because the player shouldn't be running from the start. The runners shouldn't be running from the start. So let's get right into it. All right, here we are. In the previous session, we've added the play button. Now we need some logic added to it. So let's get right into it. Okay, so let's create a new manager here under the manager's game object and call it UI manager. Okay, perfect. So let's create a new script for that. So let's open CrowdRunner scripts and let's create a new UI manager. Perfect. Let's attach this script to our brand new UI manager game object and open it. Nice. Now we want to create a new method. It's going to be a public method, void play button pressed. Okay, so let's do that. This is the method we are going to attach to our play button to detect any press of the button. And in this method, we're going to say game manager dot instance to call the instance of the game manager dot set game state, and we're going to set the game state whenever we press the play button. Okay, perfect. So now let's attach this method to our button, and to do so you need to select the play button, and under the button component, the onClick Unity event here, let's click on plus to add a callback to this event and drag and drop the UI manager right here. Now you can select any function from the UI manager component. Let's select the play button pressed we've just created. Okay, so to debug this, let's open the game manager, right so, and add a new debug.log method to be able to see stuff in the console. So let's say game state changed to plus let's say game state. All right, So now let's get back to Unity. Select the console, clear it, and hit play. Now, whenever we press the play button, it says the game state has changed to game, which is perfect for us. This is exactly what we want. So now we just need to add some logic to our player to allow it to start running whenever we press the play button and not before. So let's open our player. In the player controller script, we're going to add a small boolean here for the control, or in the settings. I think it's better. So let's create a new boolean and let's call it can move. Okay, perfect. Now we need to add two more methods, and they can be private, and let's call them start moving and stop moving. Okay, perfect. In the start moving method, we want to allow our player to move. So we can say can move equals true. And in the stop moving, we can say can move equals false. Perfect. So note that if you don't specifically say that can move equals true at the beginning, when it's created, it's going to be false. So right now, our can move boolean is false whenever we start the game. Okay, perfect. Then we want to allow our player to move only if the can move is equals to true. Otherwise, we don't want our player to move or to be able to control it. Perfect. So when are we going to start moving then? In the start method, we can subscribe to our game manager event, if you remember well. Here the game manager sends an event to whoever wants to listen. So the player controller wants to listen to that. So we're going to say game manager dot on game state changed plus equals to subscribe to this event. Let's say game state changed. Game state changed callback. And we are going to create this method to be able to apply some logic whenever the game state changed. So let's say private void game state changed callback, and it's going to take a game manager.game state as an argument. Perfect. So in this method, we want to check if the new game state is the game state. So if game state equals game, then we want to start moving. Nice. And that's it, guys. Let's get back to Unity, hit play, and now the player shouldn't be moving. The runners are playing the run animation, but we will fix this later too. Okay, so let's hit play now, right here, and now we can see that the player is moving. That's perfect. Now when hitting the finish line, it should come back to the start. All right, and it's not moving. Okay, cool. So the next thing we want to do here is to hide the menu panel whenever we press play. So we can do that by opening the UI manager script and adding here, let's say elements again, serialize field. Now you're used to it. Let's set a new game object and let's set a reference to our menu panel. Okay. Whenever we press the play button, we also want to hide our menu panel. So to do so, we just say menu panel.setActive false to disable the whole game object. All right, let's check that. So first off, we need to specify the menu panel here in the inspector. So let's grab the menu panel and drop it here. Hit play. Now we can try and press the play button. And we can see that the menu panel has been disabled. Perfect. You can imagine that we will want to show the game panel next when hiding the menu panel. All right, let's just quickly fix the runners running. Okay, to do so, we are first going to open the animator tab right here. All right, let's rename these animations. So select the running animation and call it run. It's going to be simpler like that. Let's select the idle animation now and call it idle. Okay. Now we want to set our idle animation as the default layer state. So like so, we just right click and select it. Now when we hit play, the runners should be idle. Okay, but when we hit play again, they are not running. So we need to tell them to start running whenever we press the play button. To do so, let's create a new small script and let's call it player animator. This script will be in charge of animating the runners whenever one is added or removed or we press the play button. So let's attach it to our player again. Let's drag and drop it. Cool. And in the player controller script right here, let's add a reference to it. So we can say serialized field, private, player animator, player animator. Perfect. And whenever we start moving here, we can say player animator dot start or just run. Okay. And when we stop moving, we can say player animator dot idle. And we are going to add these two methods in the player animator script right now. So let's create them. Public void run and public void idle. Okay, cool. Now we need a reference to all of our runners. So let's create a reference to the runner's parent. It's going to be simpler. Okay, so elements, again, serialized field, private transform, runner's parent. Cool. We now have a reference to our runner's parent. What do we want to do next? We want to create a loop going from 0 to the length of the amount of runners we've got. So runner's parent.child count. And we want to grab this runner. So let's say transform runner equals runner's parent dot get child I. Okay, perfect. Now we want the animator component of this runner. So let's say animator runner animator equals runner dot get component animator. By doing so, we are going to get the runner's parent and loop through all the runners, get each and every animator, and now we want to set the current animation to be the run animation. Okay, so first off, let me just drag the runner's parent and drop it here. Perfect. So now we just want to say runner animator dot play run. Perfect. And same thing for the idle animation. So let's drag this, drop it here, and just change the animation to idle. Okay, let's try this out. We need to specify our player animator in our player controller script now. Okay, let's hit play. So now the runners are idle, and whenever we hit play, they start running. Perfect. This is exactly what we want. In the next session, we are going to add a progress bar at the top of the screen just to give a small hint to the player for him to know if he's close to the finish line or not. Let's go. Alright guys, here we go. So, as we've said last time, let's create a progress bar. So, we are going to open the UI game object right here, and under the canvas, let's create a new panel. This will be the game panel. So let's rename it game. All right. Let's remove the background image from here and make the alpha 0. Okay, perfect. Let's just hide our menu panel for now. Okay, cool. And under the game panel, we are going to create a new UI element, which is the slider. Perfect. Let's call it progress bar. All right. Let's bring it all the way up to the top of the screen, like so. Okay, this is a good position. We can open the scene. Oh, yeah, that's better, sorry. And we can also resize it a bit for it to be more visible. This is a good size, I think. Okay, cool. Then we want to disable the interactability because we don't want the player to be able to interact with this progress bar. Okay, so disable it. And we want to anchor it to the top of the screen. Perfect. We are getting there. So basically, the main thing we are going to do is to change the value of the slider by code. This will allow us to make a nice progress bar. Let's just remove the handle of the slider because we won't use it. We can also change the transition method to none. All right, perfect. Let's remove the handle. Okay. Now we can change the background color of our progress bar. Let's make it a bit darker. And also change the fill area of the progress bar too. So let's make it yellowish. Okay, cool. Perfect. We already have a great start right here. What you can also do is tell the fill to fit the fill area. Same thing for the fill area. You can place it under the background like so and stretch it on the background. Okay, cool. Same thing for the background right here. Okay, perfect. And we can now diminish the size of our progress bar like so. Okay, cool. Now, whenever the value is 1, it completely fills the background. Okay, cool. Let's update this value now. To update this value, we need to know exactly what's the Z position of the finish line, because let's see, when we hit play, okay, let's select the gameplay game object and chunk manager, hit F to focus it. Okay, right now, one thing. You see now when I'm trying to click on the finish line, I'm clicking on the canvas and that's bad. I don't want to be able to click it for now. So let's disable the click. When I select the finish line right here, I can see that it's on the, let's grab it and drop it anywhere in the hierarchy. And I can see that its Z position, it's 60. Okay, I will need this value. So let's try and get it by code. Open the chunk manager by double clicking on it. And let's create a new public method here. So public, which will return the Z position of the finish line. Get finish Z. Okay, perfect. Now we need the finish game object. So let's create a game object variable to store the finish line whenever we create it. All right, so right here we can say private game object finish line. All right, and here after creating the levels, we are sure that we've created a finish line. So we can say finish line equals game object dot find with tag, because we know that the finish line has the finish tag, and this will help us store the finish line in this game object. Now we can go back here and type return finish line. That's a game object. Let's get the transform component. Let's grab its position and return its Z position. Perfect. Now we know how to get the finish line's Z position. Let's open the UI manager now. This will be the class responsible for updating our progress bar. So let's add a new element and call it, so it's a slider, so let's type slider class, but here Unity can't find it. Why? It's because the slider class lives in the Unity engine.ui library. So let's type using Unity engine.ui. And now you can see that it recognizes it. Let's call it progress bar. All right, cool. And let's create a new method, which will be public void. We don't want to return anything. Update progress bar. Perfect. So if you remember well, we've created a singleton for our game manager. We can do the same for the chunk manager because we will only have one in our game. So let's create it. Public static chunk manager instance. Okay, perfect. Let's create the awake method and same logic here. If the instance is already available, then we should destroy this game object. Otherwise, the instance equals this. Okay, cool. Now we can get the finish D easily. Let's do the same thing for the player controller, because we know that we will only have one player controller. This will allow us to get the Z position of the player controller too. So right here, we can say public player static player controller, player instance. All right. Same thing, awake. If instance is different than null, then destroy this game object. It means that we already have a player controller. Sorry, typo. Like so. Otherwise, instance equals this. Cool. We are almost there, guys. Let's go back to our UI manager now. So, to update the progress bar, we will need a %, which will be the difference between the player and the progress bar over the Z position of the finish line, because the player starts from 0. So, let's create a new float and call it progress. So it's going to be equals to 1 minus the player controller instance dot transform dot position dot Z, so that's the Z position of the player, over our progress bar, so it lives in the chunk manager, dot instance dot get finish Z. All right, we have our progress now. So we can apply to the slider, to the progress bar. So let's say progress bar dot value equals progress. Perfect. So first off, when we start the game, let's set our progress bar dot value to 0 because we haven't started yet. And then in the update method, we can call update progress bar. Cool. To avoid updating the progress bar every frame, it's better to check first if we are in the game state, because if we are in the menu state or the level complete state, it's useless to update it. So if game manager dot instance dot is game state, and we are going to add this method later, if this is different than the game state, we can simply return. Okay, perfect. So now let's select our isGameState method, copy it, go to the game manager and drop it here. So public boolean, like so. And now we know that this is the game state only if the game state variable of the player equals gamestate.game. And we can just return this, like so. All right, perfect. Let's try this out. So first we can select our UI manager right here and assign our progress bar. So where is it? Here it is. Now that we've assigned the progress bar, we need to add the logic to hide and show the game panel too, because if you remember, we did it for the menu. So right here, let's create a new variable. Okay, game object, game panel. Okay, let's go down there, and when the play button is pressed, we can say gamePanel.setActive true. This way we can enable the game panel whenever we press the play button. And before that, in the start method, we can say gamePanel.setActive false. We don't want the game panel to be active from the start of the game. Okay, cool. Should be nice now. Let's specify it. All right, hit play. Oh, I need to enable the menu, I forgot that. Okay, let's hit play. Like so. And now the progress bar is diminishing. It should be the opposite. So let's go back to our code. Here it is. Okay, let's remove the 1 minus here. Perfect. And we should be good. Awesome. And now you can see that the progress bar will fill once we reach the finish line. Cool. Perfect. In the next session, we are going to try and add a level text over the progress bar just to know the level we are playing right now. So stay tuned. Hello. In this lesson, we are going to see how to add a level text above the progress bar so that the player can know which level he's playing. Let's get right into it. First off, let's click on the UI game object right here and develop the canvas here. Under the game panel, let's create a new text. So select UI text. All right, perfect. Let's call this one level text. Cool. Here it is. It's really small now in the game view, but let's make it bigger. So first off, let's align it to the center. All right, cool. Let's press F in the scene view to be able to focus it. And then we can press T to select the rect tool. Okay, let's make it a bit bigger, like so. Let's increase its size. Okay, now we can see it better. And let's tick the best fit option right here. Perfect. This way it will fit the rectangle perfectly. Okay, now let's bring it all the way up above the progress bar. Okay, right here. So now we can see that it's a bit bigger. So let's make it smaller. Okay, maybe just by diminishing the size of the rect. Okay, like so. Yeah, I think it's pretty cool. We can also change the font to the font we've downloaded. So Milky Coffee. Okay. And let's just write level 5. Okay, cool. I think we can make it white. It's going to be more visible. And we can also add an outline component to be able to see it even better. So here select add component and write outline. Okay, perfect. We can give it a proper alpha of 100. And yeah, maybe let's say we can set the X and Y effect distance to -3 and -3. Okay, cool. Now we can see the text even better. Perfect. Let's now see how we can change this value, so the value of this text, by code. For that, let's select the UI manager right here under the manager's game object and double click it. Okay, perfect. So now let's add a new element. So I'm going to say serialize field to create a new reference to the text. It's going to be a text component and let's call it level text. Okay, cool. Now, what we want to do is to change the value of the text whenever the scene is reloaded. So whenever the start method is called here in our UI manager. So I can simply say right here, level text.text to change the text value of our text component equals blah, blah, blah. So now I need to get the data. What are we going to write right here? We can already say that we are going to write something like level plus blah, 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 which is the data containing the level, the index of the level we're currently playing. For that, let's create a new method under the chunk manager because it is the class responsible for creating the level. So right here, I can say public integer because we are going to return an integer, get level, like so. And here I'm going to say player preferences. So player preferences is a class that is used to save data. You can save an integer, a floating value, or a string, and it's going to save it in your device. So now I want to get an integer, and I want to get, let's say, a level key. So here you need to specify the key of the integer you want the player preference class to return. So in our case, we can just call it level. So at start, it doesn't exist, but we are going to create it this way. Okay, so we can just return this. Return this. Okay, so now let's just check if this is a singleton, and it is, of course. So let's go back to the UI manager, and line 21 in the start method, we're going to say level plus chunk manager dot instance dot get level. That's it. So let's get back to Unity now and hit play. But first, before hitting play, we want to specify our text game object right here, our level text game object, like so. And now we can hit play. So when we hit play, we've got level 0. Cool. It means that we've changed the text at least. So in the chunk manager class, in the get level method, if you haven't initialized this player preference object, it will return a value of 0 for the integer. Okay, so now we can specify a basic value of 9 if we want. Let's try. Did I save it? Yeah. And now it's going to write level 9 because the default value for the key level is now 9. Okay. So now let's just say 0. Let's just say 0 if we do not find a value for this key. Okay. Now what we want to do is increase the value of our level integer in the player preferences by 1 whenever the player crosses the finish line. I'm going to jump to where we've specified this code. So I think it was in the player controller. Nope, it wasn't. It was in the player detection right here. It was here. Okay. So before reloading the scene, what I want to do here is to call the player preferences class and say set integer, and we're going to set the value of our level integer. And we're going to set the current level. So the current level is player preferences dot get integer level. This is our current level plus 1. Let's increment it. Okay, perfect. So before going back to Unity, I'd like to change the value here in our UI manager because the default value is 0. So I want to start showing the level to the player from 1. Okay, should be good right now. Let's go back to Unity and hit play. So right now we are playing level 1. Okay, let's wait for the runners to hit or to cross the finish line. Now when we hit play, it doesn't work because of something we haven't fixed yet. So let's fix it right now. Whenever a class subscribes to an event like so, so now we've subscribed to the on-game state changed event from the game manager. When we reload the scene, we destroy everything. So we need to unsubscribe from that event. To do so, we can call the onDestroy method from this same script. And instead of adding our method to the event, we need to remove it from it. That way we won't have an error when reloading the scene. Okay, let's hit play right now. So now we already have level 2 because we've crossed the finish line. And let's cross it again. Let's hit play. And now we've got level 3. Perfect. This is working, guys. So right now our level consists of only, let me check here in the chunk manager. Let's pause the game first. It only consists of 3 chunks and we don't have a way to save our levels. So this is exactly what we're going to see in the next session. We are going to create a level class which will hold an array of chunks so that we can create more and more levels. Let's get right into it. All right, here we are. In this lesson, we are going to create a new type of object, which is the scriptable object. This will allow us to store data for our level. In this case, the level will only contain an array of chunks or a list of chunks for the chunk manager to spawn a level correctly. So let's get right into it. Open the CrowdRunner folder, and under the scripts folder, let's create a new script and call it level scriptable object. So just SO. Okay. So double click it to open it. Cool. And this class, so the level SO class, will not derive from monoBehavior. This one will derive from scriptable object. So we can already remove our start and update method. We won't use them. Okay, cool. To be able to create a scriptable object from the editor, we are going to add an attribute right here. This attribute will be create asset menu. When you create this attribute, you need to specify 3 arguments: the file name, the menu name, and the order. So let's do that. Let's say file name equals level. Menu name will be equals to scriptable objects. That way we can store all of our scriptable objects under a same category, and then level. Then we can say that the order of this scriptable object will be 0 to be able to see it at the top of our list. And by list, you'll see what I mean in a moment. Okay. As we've said previously, the level SO class will only contain an array of chunks. So let's create it. It's going to be a public chunk array of chunks. And that's it. Let's go back to Unity and see if we can create our level scriptable objects. So for that, let's create a new folder under the CrowdRunner folder, and let's call it levels. Okay, let's open it. Then right-click, create, and at the top, you can see that we now have a new category to select. So we can select our level scriptable object we've just created, like so. So let's call it level 00. Okay, cool. In our level 00 now, we can specify an array of chunk. So let's create one, let's say. Let's right click on our level and select properties. This way we have a new window that will show our level scriptable object. Okay, we can go back to the prefabs folder, chunks folder, and now we have our chunks that we can drag and drop into this new window we've created. Okay, so the level 00 will start with a medium chunk. So a medium chunks like so, which is empty. Then we can have a medium chunk with doors. If you click on it, you can see in the inspector that it has 2 doors. Okay. And then we want to have a long chunk, let's say, like so, which have 2 doors, if I remember well. Perfect. Then we will finish the level with the finished chunk. Okay, perfect. We've got our first level. So now we just need to add some logic to the chunk manager. That way we can input our level data and he will create the level for us. Cool. Okay. Let's open the chunk manager now. We can already remove all of the elements we have, like so. Maybe we can keep the finish line for now, but you can remove the chunks prefabs array and the level chunks array. And we will replace them by a new array of levels, level SO, sorry, like so. Let's call it levels. Cool. Now we've got some errors because it's not able to find the arrays we've deleted. So let's remove these methods like so. You can store them somewhere if you need them, but in our case, we won't. So let's remove them. That way the script is cleaner. Okay, we can also remove this or replace it by a new method called generate level. And let's create this method right now. Private void generate level. Perfect. What do we want to do in this generate method? First off, we want to select the correct scriptable object. To do so, we need to have the index of the level the player will play. So we already have it right here in the getLevel method. So let's say int current level equals getLevel. Perfect. Then we are going to write level SO. So the level we're going to use, level equals levels. We're going to search in the levels array, the level with the index current level. Okay? But wait, what if our current level is greater than the length of our levels array? It will return an error. So for that, we first need to check if that's the case or not. To do so, we can clamp our current level. There is a small trick you can use here, is to make the game endless. So it will play all the levels in a loop. To do so, we can say that current level equals current level modulo levels.length. That way it will never be as long as the length of our levels. The modulo operation basically just takes the remainder of the division between the current level and the length of the levels. So this can never be greater than the length of the levels. Okay, let's try this. Now that we've got our level scriptable object, let's generate all of the chunks of this level. And of course, I shouldn't have deleted the previous methods, so I'm putting it right back here. Okay, perfect. Because we are gonna use the same logic in our new generate level method. Okay, cool. We can rename this method to create level. Okay, and instead of having no arguments, let's add a new chunk array argument like so and call it level chunks. Perfect. This fixed our error first, and then it allows us to specify an array of chunks that we want to create. Perfect. Because if you remember, in the level scriptable object that we have right here, we have an array of chunks we want to create. So it's going to be very easy. We can say create level and pass in the level chunks. That way, it makes things very easy to edit. And we're pretty much done. So let's go back to Unity. Okay, let's select the chunk manager. And in the inspector, let's drag and drop our level. So let's lock it for now. Let's go to the levels folder, drag the level 00 and drop it in the levels array. Okay, let's hit play now. We should have our level created. Perfect. So let's hit play and play a little bit. So times 10. Whoa, we have a huge amount of players right now. 46. Okay. Now there is another error we are going to fix later on. Perfect. You see that it has created the level 1 again. That's pretty neat. Okay, cool. So in the next lesson, we are going to fix the bug you've just noticed that when we add some runners, they don't run. They are not playing the run animation. And this is exactly what we are going to fix in the next lesson. So let's get right into it. All right, this lesson is going to be quite quick because the bug we want to fix is not huge. So perfect. Let's select the player and double click the crowd system. Okay, perfect. So whenever we add runners, the thing we want to do here is to tell the player animator that he has to make all of the runners run because we have some new runners. So let's let him know. How are we going to do that? We can specify the player animator right here, and I think that it's a pretty easy way to do it. So let's do that. We are going to create a new field for our player animator, like here, and call it player animator. Okay. Then, whenever we add runners, as I said previously, we want to call the player animator and tell him to make all of the runners run. So let's just call the run method. And now we can go back to Unity. Drag the player animator component onto our new field and hit play. Okay, we can now play the game and see. Perfect. All of the new runners are running. That's cool. I told you it was going to be a quick lesson. But now I feel that the game is quite easy. So why don't we add some enemies to spice up things? All right, let's do that in the next lesson.
Thank you for watching. Subscribe now and press the bell icon. Never miss any update.